Today's lesson is all about the future value of an amount, which is part of the time value of money, one of the four kinds of cash flows. And today we're going to solve problems that deal with a situation where you know what the present amount of something is. That is, you have some dollars here and you're going to put them into something, invest them or put them into something, and then you're going to let that time go by, in this case for 5 years, and ask the question, what are those dollars worth, in this case 5 periods or 5 years out into the future. So the way we're going to solve these kind of problems is we're going to ask the question, what table do I use, and what's my interest rate, and what's the number of periods. And the formula we're going to have is, it'll be the future value of an amount is going to be equal to the present value times the table value, and it'll be the table value for the future value of an amount, which will be in the back of a book somewhere, and you'll have to know in most cases the interest rate and the number of periods. So here we go. If $712 is invested on February the 1st of 2006 at an annual interest rate of 12%, how much will accumulate by February the 1st, 2009 to the nearest dollar? Now I've got all four of these kinds of tables we're going to use, which are the same in the back of your book. They may be, like I said, labeled a little differently, but we have the present value of an amount table, the future value of an amount table, the present value of an annuity table, and the future value of an annuity table. So the question is the unknown that we're looking for in the present, or is it in the future? Well, we know in the present is $712. The question is, how much will that accumulate to 3 periods from now at 12%? So the unknown is in the future. And is it a lump sum, or is it a series of equal payments? Well, it's a lump sum. So we're going to use table in my book, it'll be table B2, but in yours it'll just have to say the future value of an amount of $1. That's what it should say. So we're going to use, like I said, in my book it's B2, and the formula is the future value of an amount is equal to the present value times this table value based on an interest rate of 12%, and a number of periods will be 3. So let's plug in what we know. We know that the present value, which is today, is worth $712, and if you look up the table, you'll see that 12% for 3 periods based on this future value of an amount table is 1.4049. And when you multiply these together, that means that 3 years from now, if you can earn 12% interest on $712, that means it's going to be worth $1,000. Now, here's what we just did. We just used these future value tables. We could have used some formulas, or we could have used a calculator, or we could have used a website, to go to the computer and use a website. But we chose to do this. We looked at 3 periods, and we looked at 12% interest rate, and that was a table value we used. And you can see that when you multiply $712, that is the amount we have now, by that table value, you'll get what the amount will be worth 3 periods from now at 12% interest, which is $1,000. Here's another way to look at the same thing. If you put up $712 right now and can earn 12% interest on it, in 1 year it becomes worth $797. And since we're getting compound interest, then we're going to take that $797 times another 12%, and it'll be worth in another period $893, and then finally in the third period it'll be worth $1,000. Okay, let's go on. Now this is using the same information, except this time we're not going to be keeping the money out for a whole year. So if $712 is invested on February the 1st of 2006 at an annual interest rate of 12%, how much will accumulate by July 31st? Well, this is basically 6 months. And so when you have a situation where you have less than a year and your tables are all based on annual interest rates, here's what you have to do. Let's go on through this little process first. Is the unknown in the present or the future? Well, the unknown's in the future. It's 6 months out in the future. And is it a lump sum, or is it a series of equal payments? Well, it's a lump sum because we only put in one amount. We're not putting in a series of equal payments. We're just putting in one amount. And so we're going to use table B2 again, or the table we're going to use is called the future value and amount table. And this time, since we're only going to keep it out 6 months, we're going to use the following. We're going to use 6%, which is half of the 12% interest rate because it's half a year, for one period. So if it's less than a year, in this case half a year, if it's a 12% annual interest rate, then it'll be 6% for 6 months, or half a year. So that table value will be 1.06, and I think I dropped off some of the other places, but it's 1.06 times $712. So 6 months from now, $712 at an annual interest rate of 12%, which is a 6-month rate of 6%, will be worth $755. This is a partial year future value and amount problem. Another kind of problem. If you invest $5,000 today in a stock mutual fund that earns 12%, how much will it accumulate in 10 years? Alright, this is a little different kind of situation. We know the present amount, which is $5,000. We also know the future amount because it said how much will it accumulate. Well, I'm sorry, we don't know that. We know how much will it accumulate in 10 years. Well, we know 10 years and we know 12%, so let's see if we can come up with the future amount here. The lump sum is what we're looking for, and the unknown is in the future. So we're going to use, again, table B2, and it'll be based on the future value and amount table based on 12% for 10 periods, and you can look this up. And we know that the present amount is $5,000, and we know that table value is 3.1058. So that we can say that $5,000 earning 12% interest for 10 periods or 10 years, it'll be worth $15,529. Okay, now let's look at another situation. If you invest $20,000 today in a stock mutual fund and wanted to double your money in 7 years, this is what I thought I had in the first place, but now I've got a situation where I know the amount today, which is $20,000. I know the amount in the future because it's going to be $40,000. That's doubling your money. And I also know the time, which is 7 years, but I don't know the interest rate. So this is one of these situations where if you know 3 of the 4 parts, you can find the 4th part. So let's see what we've got. The unknown, present, and future, that's really kind of irrelevant for this problem because we know both the present and the future. And they're both lump sums, so that's kind of irrelevant also. But here's what we want to focus on. We want to use table B2, which is the future value and amount, equals the present value, times the table value based on what interest rate and what number of periods. So let's plug in the pieces that we know. We know, for example, that the future amount is $40,000. That is doubling your money, right? Which is, if we know today was $20,000, doubling our money is going to be $40,000. So the future amount is $40,000. The present amount is going to be $20,000, and the table value will be based on 2 things: the interest rate, which we don't know, but we know that the number of periods is 7 periods. So here's what we need to do: $40,000 is equal to $20,000 times what? Well, times what would be 2. 40,000 times 20,000, excuse me, 40,000 equals 20,000 times 2. So the table value is going to be 2. So if we're looking for what interest rate is going to be required to do this, and we know that the table value is 2, and we know that the number of periods, interest periods, are 7, here's how we can solve this. We go to 7 periods and we look under 10% and 12%. That's the 2 that are in a row right there. And you can see that under 10% for 7 periods it's 1.9487, and for 7 periods at 12% it's going to be 2.2107. So it looks to me like that the interest rate that's closest to these 2 would be a little more than 10%. So what we can say is, if we want to double our money from $20,000 to $40,000 in 7 years, we're going to need to earn an interest rate that's a little more than 10% interest. So that's how you solve that one. And then this one, we've got, if you invest $8,000 today in a stock mutual fund and wanted to double your money, and could earn 15% rate of interest, how long would it take? So this is a little like the last one, except that we know the interest rate and not the number of periods it's going to take. So again, if you know 3 of the parts, you can find the 4th part. And so, is the unknown in the present or future? Well, we know both. We know the present is going to be 8,000 and the future is going to be 16,000 because we're doubling our money. Is it a lump sum or a series of equal payments? Well, it's a lump sum. Both amounts are lump sums. And which table are we going to use? We're going to use the same table we used before, which is the table which is the future value of an amount or a single lump sum. And so we're going to plug into this table the things that we know. And what we know is we know that we know the future value, we know the present value, and we know one of the things about the table, which is 15%. So 16,000 equals 8,000 times something. Well, 16,000 equals 8,000 times 2. Again, the table value is 2. So we're going to go across the interest rate to 15%, and we're going to see that 15% for 5 periods is 2.011, and 15% for 4 periods is 1.749. So I would say that if we wanted to double our money, go from 8,000 to 16,000, and our interest rate was 15%, that's going to take us just a little bit less than 5 periods, or you could say probably about 5 periods. So 5 periods or 5 years would be the answer. So that's the end of our lesson.